Hey, good evening, everybody, and welcome to, I guess, what we call a special Monday edition of Third Thursday trainings, live online trainings for the Mountain Rescue Association. I'm Charlie Szymanski, and I'm privileged to be the Education Director for the Mountain Rescue Association, and super excited about tonight's presentation. We actually have presenters from literally all corners of the world today, coming to us live from Switzerland. Manuel Genswein, one of the foremost authorities in avalanche rescue and avalanche science and research, where by my watch, it's about 3 o'clock in the morning and Manuel's with us live. And also joining us today is Øyvind Henningsen, who is the MRA's Safety.info coordinator. And Øyvind, who normally lives in the state of Washington, is actually in Hawaii right now. So we're literally coming to you from all corners of the world. Before I introduce Øyvind and Manuel, I want to first start by telling you just very briefly about Safety.info. It's one of the newest additions to the MRA education program. It's available to MRA members through a subscription service. You'll find on the MRA website instructions on how to enroll yourself as a user of the Safety.info program. I won't tell you much more than that because that's what tonight's program is all about. I first do want to tell you about our two presenters. Øyvind Henningsen is a operations leader and rescue member of Everett Mountain Rescue in the state of Washington, and he is the team coordinator and rescue technician with Snohomish County Helicopter Rescue Team. Øyvind is also an MRA delegate to the International Commission for Alpine Rescue. He's a delegate to the Air Rescue Commission because of his expertise in helicopter rescue. And Øyvind is going to be serving as the, again, coordinator for the MSI subscription program. You'll find Øyvind's contact information on the MRA website with the MSI information as well. Øyvind will be joining us later for the Q&A sessions, and we're just super appreciative of Øyvind's work. And then finally, I want to introduce our keynote speaker tonight. His name is Manuel Genswein. It's a name that's not unknown to most of you. He's been involved in avalanche science, avalanche research, and now is foremost worldwide avalanche educator through the development of his Safety.info website. He's done snow science and safety work and taught in 30 countries throughout the world. He's got an electronic engineering background. I first met Manuel in Iceland, gosh, maybe 15 years ago. And the work that he continues to do year after year is really quite amazing. He's developed rescue products and techniques that have been used worldwide. He was the one who developed the V-shaped conveyor belt shoveling technique for avalanche rescue, which he's going to spend a little time telling you about. I've had great fortune of having Manuel here in Colorado, working with us with the Flight for Life program on our avalanche rescue program. Tonight, he's largely here as the founder of the Safety.info database, which is now being used worldwide, database of mountain safety and rescue training materials. So without further ado, ladies and gentlemen, Manuel Genswein. Manuel, take it away. Good morning, Manuel, by the way.
Thank you very much, Charlie and Øyvind, for your very nice introduction, and of course as well, thank you to both of you for your very long support of this project. Øyvind, as you have heard, has as well been over many years actively involved in the creation of Safety.info, in the build-up of these work groups by participating in our work group meetings very practically. I'm going to share now my screen with you. The startup picture, Safety.info, where you see as well some of the institutions and organizations which stand behind Safety.info, as it has already been mentioned by Charlie. And I would like to say a few words about the initial motivations and reasons for the development of this project, for the development of Safety.info. My background is in the research and development for solutions, systems, methods, strategies in the domain of snow, avalanches, avalanche rescue. I do that for the last 28 seasons by now, and I teach in 30 countries. And yeah, about 10 years ago, I just started to realize more and more that we are not using the spare resources we have available in our domain in a very efficient manner. In particularly, I really have seen more and more the pattern that every nation and every organization tries to reinvent the wheel again, hires again an artwork guy to do another imperfect copy of something which basically already exists. And therefore, I try to outline a little bit the necessary steps which would guide us towards a more efficient and more sustainable collaboration model, which would, for example, mean that we would do common research and development projects, common field tests, common laboratory tests. As you may imagine, these are resource intense, costly things, and it is obviously important that one already gets to a consensus what exactly to test, what exactly to measure, because if you basically don't agree on how the field tests are made and the data is gathered, obviously you will not agree on the outcome, on the findings either. Once you have come to consensus on best practice, you obviously need to make translations. Translations are something very time consuming. And when you want to make good translations, you have to ensure that the translators really understand in all the fine practical details what it is about. Therefore, our translators, they are all work group members and instructors. They have all worked with us practically in the field and understand all the little things. How do you exactly need to hold the shovel, or do this and this part of the rescue, so that they are able to make a very concise translation. Illustrations and the videos as well, this is something expensive. It's as well something where one needs external professionals. So therefore, as well concerning this, it really makes sense to do it once, but then to do it properly, to get all the ideas of the different work group members before you start doing the illustrations and the videos, so that the end result will satisfy the needs of the different user groups and user levels. The creation of the best practice consensus is therefore as well moved to the international level, and concerning this, it was really important to me from the very beginning on that there's not only one user group, but there are all the major user groups around the table. So we have representatives of the world of organized rescue, of professional guiding, of the alpine clubs, of the military mountaineering schools, of the snowmobile user group, of the user group who is responsible for the safety, the avalanche safety, now in the case of the first work group on roads, railroads, or in villages. So every different perspective you can have concerning one of these topics of mountain safety. if you don't have the different user groups and the different user levels represented around the same around the same table in the phase of creation of the best practice consensus, obviously you will not be able to provide content at the end which will be accepted by a wide amount of user groups. All this should be recorded in a database, which obviously then means as well it is properly structured, properly stored. We have created our own online database and our own content management system for this, with the goal to provide to the different nations, organizations, but as well individual instructors or mountain guides who are teaching courses to build their courses, their PowerPoints, their instructors manual, their course curriculums based on this database, but they're not forced just to take everything. They can basically select from the many different elements we offer what is most relevant for their user group, for the user level, for the specific application environment and the terrain they want to target with the specific course they prepare content for. So how did we practically create the content? Obviously, there is a lot of existing knowledge already, and that is obviously very much taken into account. But for everything which is in the database, we try to find as well scientific evidence. We would like to avoid that things are just based on expert consensus, because expert consensus is always potentially subjective. It has as well the lowest level of evidence. We try to do better. We try to create quantitative evidence. We look at retrospective data, so statistical data. And we, of course, create as well prospective data with field and laboratory testing. That means that we need as well to launch our own research and development projects when we realize in a certain topic, in a certain field, there are no clear trends, or one really is not satisfied with the existing solution. So one needs to really make a wider project to find out in which direction one should go. And yeah, for that, of course, one needs again to do field test, laboratory testing, looking at the statistics to have good proof where the journey should go to. This is obviously all done with the active participation of the different user groups, and all these components together here are then going into the best practice consensus. And once we have best practice consensus in English, which we obviously use as our base language, then we start the translations. And by now, these are already 20 languages. And therefore, even once we have reached best practice consensus, there is still very substantial work to be done until we are here where we can say, okay, for this topic, we have the illustrations with the key terms here already lying on the top of the illustrations. Then we have a certain instructional text text, and we have the references to the different scientific papers, or as well existing recommendations, for example, UIAA or ICAR recommendations. So basically, our approach is we take the existing knowledge that includes as well all the expert know-how, but we try to validate it with scientific evidence. We, for example, make field tests or in certain cases, laboratory tests. I collaborate, for example, with the UIAA SafeCom concerning avalanche rescue equipment. We use statistical data. We make our own research and development projects, and we include, as previously mentioned, all these user groups. That all together gives then the best practice consensus, which we translate currently in already about 23 languages. This morning in Europe, I start with the Greece translator, so very soon the mountainsafety.info material will be applied on Mount Olymp, translated into Greece. Here we have our knowledge base. Most of you I have seen have already signed up for it. This is great. Most of you have started to download content. Perfect. And you have recognized what we offer are illustrations with the key text elements overlaid to it. We have as well written content in the future. Concerning written content, we will as well have pedagogical, didactical text, which are basically the instructor's note. There are teaching aids, which are basically composites of many pictures and illustrations for a specific user group or user levels. We make reference to international recommendations, and we have as well videos. All the videos are made. We are just about to release them on the website. And of course, we have different books already which use our materials. I can show some of them. Then you really see the point of this. Just have to switch over here a little bit. And I'm sorry, I start the screen sharing again with you. So you should see here the camera. We have here, for example, the manual of the Italian Alpine Club, the ski mountaineering manual. And as soon as we go here towards avalanche rescue, you find here all these different images from mountainsafety.info. So the Italian Alpine Club took advantage. You do see my shared picture, Charlie, is this right?
Sorry.
Okay, perfect. Yes, excellent. Or as an example from the United States, many of you certainly know the book of Bruce Tremper, Staying Alive in Avalanche Terrain. And here it's the same. As soon as we open the companion rescue picture, you see here pictures coming from the mountainsafety.info database. So instead of trying to reinvent the wheel again, many authors of books, here an instructor's manual for the Swedish Armed Forces, took the decision it is much more sustainable to take something out of this international database. And that was exactly the goal I wanted to achieve. Share the resources, develop it once, then reuse it in as many teaching tools, videos, books as possible. What are the 4 different important principles on which mountainsafety.info is based? We have here best practice and the evidence-based approach. So we on purpose strive to do better than just expert consensus. You might be aware of when we look at evidence in the scientific picture, then expert opinion is the lowest possible level, because expert opinion has a lot of subjectivity. In a field where statistical data is not available in very large quantity, it is hard to completely leave out expert opinion, but we just have to take a good balance between some expert opinions, but then as well to try to combine it with prospective studies and statistical data. Cultural diversity. It is not at all the goal of Mountain Safety.info to say, look, this is the only allowed solution to solve a different problem. We allow different solutions to solve a specific problem in Mountain Safety.info. However, we have as well some rules concerning cultural diversity. If we include different approaches for the same problem, these different solutions must show a similar level of efficiency or user error tolerance. Individual use, so the goal is not that every PowerPoint and every instructor's manual looks exactly the same in the future all over the world. No, the approach is that you can pick and choose exactly those contents of the MSI database which are relevant for your specific user group, your specific course, your specific mountain range, and you mix it as well with some personal content to make these presentations or this content lively and targeted to the goal of the lesson you want to deliver. The fourth tower here is that we act as a community management organization. That means that we provide as well a certain institutional framework for the authors with some protection for their intellectual property. So when you buy content from MSI, there is a small development amortization fee going back to the authors. And in this respect, you have to understand that the low-hanging fruits, they're all taken for us who do nothing else than research and development in the field of mountain safety. So every project for a new method, system, technique, strategy costs a lot of time, money, and resources, and we can only continue this work in a sustainable manner if there is some participation of the mountain community, mountain sports community at large in these development costs. However, the Mountain Safety.info is quite a particular CMO, community management organization, in the fact that we are not just protecting any works, any development. The development projects need to be verified by the work groups. So there's a filtering and a selection process to make sure that what is then really available on the public site is fulfilling the quality requirements of Mountain Safety.info. And you see here a picture of one of our work group meetings, the one from 2018. We started about 5 to 6 years ago. We had the first work group meeting in 2016, second 2017, third here 2018, already with 18 nations included. And Oivin always was part of these meetings from the very beginning on, and I'm very thankful to Oivin and of course to MRA that you were supporting this mission from the very beginning on. It is really all these individuals together who have made it possible to start this project and to be where we are today. So thank you very much, Oivind, and of course as well, Charlie, for your very early support. What is our working method? We choose working locations which are really in the mountains. I think Oivind can confirm that. We are not selecting expensive conference hotels. The advantage of our mountain sites as workplaces has the advantage that the theoretical indoor part is extremely close to the outdoor part. That is as well the fact when it comes to creating illustrations or videos. We have here our artwork guy who comes to this mountain hut close to the glacier, and when we are coming inside from the field, we can immediately look at the images and the illustrations he has adapted or created for us in the meantime, and we fine-tune the texts and the new illustrations in a very dynamic yet very efficient development process. Practical example here concerning an excavation strategy. So these would be our illustrations, and then you have a text coming with that, and in several cases as well a video. For now, the videos are kept language neutral. This is less costly, and thanks to the fact that we make these illustration overlays to the video, we can show, let's say, the more theoretical abstract approach of the illustration combined with how it looks in the reality, to have both worlds, theory and practice, combined and visualized for the student in a combination which is most efficient for the learning process. With that, we stop the intro. You see, have seen a little bit behind the concept of MSI, and in the remaining about 1.5 hours, I will now walk you through the different content we have. We will not go very deep into technical details. My goal is really to show you what components are available and how these components are linked to each other, so that when you start using the content to teach in your own rescue group, in your own organization, then you understand the big picture of the content. You understand how you can as well hierarchically structure a lesson, and you will find the individual puzzle parts, the individual contents, and how you can integrate them in your course. We start here with group check, and for every content I will point out that the key components, and therefore as well the key messages you should consider to mention when you deliver this. And I am focusing a little bit on these points where I know that in the US they are particularly important. Concerning group check, for example, it is very important that people understand that a properly done group check is nothing else than a range check. You can do a range check in 50-60 meter distance when the transceiver is on a very high volume or 70 or sensitivity setting, but you can do the equal range check in a much shorter test distance. For example, here 1 meter, when the volume or sensitivity setting of the device is accordingly set to this distance here, about 1 meter. And this is exactly what happens when you prepare for a proper group check. Either your transceiver has a group check function. When this is the case, use it in group check. What is the group check function of your transceiver? A group check function is a search function which is specialized on the range of 1 meter and which has the advantage that it's not only testing the amplitude of the signal, but as well additional parameters such as the pulse rate or the transmit frequency. So using the group check function to do the group check leads to more thorough, more detailed, and more reliable check. On the top of it, group check functions, as they are offered today by the majority of all manufacturers, have as well a safety advantage in the fact that it is impossible for the group leader to start the tour in group check or receive mode, because these group check functions are all programmed in a way that after a short while, the device will switch automatically to the regular send, thus transmit function. Transceivers without group check use the normal search functions, and I hope that we don't have to speak about analog only devices anymore. So what is the point about a properly done group check? We have here a predefined test distance, and we look for a predefined result. And this predefined positive result is either an okay result from the group check. What is an okay result from the group check from your specific device? This is something you have to check in the user's manual. It can be an okay message. It can be a beep sound. And for all the devices who show a distance indication here, the distance indication must be smaller or equal to 2.0. And with this example, smaller or equal to 2.0, you understand the quantitative approach of this field, of this range check. As soon as the transmitter has any sort of problem, either the batteries are getting very weak, or the antennas have a problem, or the electronics have a problem, that will always lead to the fact that the transmitter will transmit a weaker signal. So the receiving device will receive a weaker signal. Thus, it means that it's further away. And as soon as we are not within the minimum threshold of 2.0 or smaller, the result is failed. So you see, we have a very clean quantitative range check where we ask for a specific test distance and we ask for a specific test result. When you do a group check like that, which doesn't take any more time, it just takes a little bit compliance to a protocol, and especially to the fact that you need to maintain those distances, then you have every morning at least a quantitative range check on all the devices. And this totally replaces all the other forms of range checks. So those ones of you who do range checks at 50, 60 meters, forget it. This is not very practical in the morning anyway. Do the range check as part of the systematic group check procedure, as you see it here in the MSI information, and you have the same result, the same technical quantitative verification in exactly the same way. The only thing you're absolutely not allowed to do is to go closer in case there is no positive result at 1 meter test distance, because then you can cheat. And I can show that quickly to you. I turn on here a transmitter which transmits only 20% of what a normal transmitter is transmitting. So very clearly, this device has a big problem if it transmits 5 times weaker than normal. Now we have here the test device, and here when I'm about at 20 centimeter distance, the result is negative. But when I get close, then it says here, okay. So you realize we can really cheat. If we go very close with the device, we think, oh, beep sound, perfect, everything is okay. So you must maintain a test distance, which is this 1 meter at least. And if there is no beep sound or whatever is considered as a positive result from the specific transceiver you use, then this is an alarm sign. And you must really check what is with this device. When you get closer, you can cheat. This is what happens now. It says, okay, we have just created a so-called false positive. So respect the test distance. That makes a group check a quantitative range check. With this, we go on and we quickly treat the topic of interference. Unfortunately, a topic which becomes more and more of an issue as we take more and more electronics into the field, in despite of the fact that everyone would like to enjoy the nature and the calm of the mountains. People are contaminating the scene with all kinds of electronics. For the beginner level, you see here our content, which is based on the strategy of avoiding interference. Total beginners are unable to master the complexity of leading a search in an environment which is on the top of it, disturbed by interference. Therefore, they simply have to turn off all their electronics while they are in search mode. And please realize that today the search is only taking such a very short amount of time, looking at the entire rescue time, that it really doesn't make sense to take a risk to be misled by false positive created by the interference of your cell phone, of your helmet cam. Switch off these devices. Whereas this is a good strategy for the beginner level, it is of course a completely incompatible strategy for a mountain, avalanche or rescue professional. Therefore, MSI offers for the same topic interference as well a puzzle part, which allows you to use all the electronics while you are searching, but now in connection with a user who really understands what is the potential influence, a user who can distinguish between a false positive and a real signal, and a user who can as well master a proper search in a heavily disturbed area. Let's look at these three components: understand, detect, and master. What are the causes of interference? Looking at these devices we have on us, your rescue radio, your cell phone, your GPS, they are prone to lead to misleading distance and direction indications, so-called false positives. And today, unfortunately, there are obviously rescue missions who have been gone totally wrong because people have walked along false positives for 10, 15 minutes, 100, 150 meters away from the buried subject. And instead of looking for real signals, they were turning in circles. What the second influence is range reduction. However, range reduction only occurs when we speak about very strong interfering sources, such as here, power line, a high tension power line, such as ski resort equipment, which uses a lot of power, as well radio transmitter stations, cell phone transmitter stations. How can we differentiate a real signal from false positives? This is a domain where analog sound is still an advantage. When you hear analog sound and you have distance and direction indication on the screen, you know this is a real signal of a buried subject. So you hear the distinct beep, beep, beep sound, and at the same time you see distance and direction on the screen. You can trust it. However, when you see distance and direction indication only, but the analog sound is missing, this is a false positive, for example, created by the loud setting of the loudspeaker of your radio. And as soon as you realize the analog beep sound is missing, you simply filter it out as a false positive. You have certainly realized that we have today, fortunately, again, several manufacturers such as Peeps with the Guide Pro, such as Verivox, such as Arva, which do offer for the highest user level devices, which not only offer a modern and user-friendly digital receive mode, but as well an analog sound in order to let you take advantage of the only advantage which is left for analog: reliability. Analog is very reliable because it is untreated raw data, and analog and digital is not at all in competition with each other. Analog and digital is complementing each other. It's complementing the user friendliness and the ease of use of digital with the reliability of analog. When you are searching in heavily disturbed areas, and this is often the case when you are in ski areas or very close to ski areas, or you are somewhere in a mountain pass, and over the mountain pass there is as well a high voltage power line, then you will realize that interference will be very heavy. How can you detect that the interference is heavy? One possibility is just subjectively, you look around, you see the type of equipment around you, and you make your estimation on that. When you have analog sound, of course, you can listen to the background noise, and in case you have a instead of just a then you realize something is wrong. And you see here what are the adaptive measures to make sure that your search will still be successful. Cut search strip width in half. And now we quickly analyze this situation together so that you really understand what is going on here with interference. And this is as well an excellent preparation to what we have to do later. So you should now see here our whiteboard, and on our whiteboard we have here amplitude, and we have here the time. Now we look at the situation with very low interference, as it is normal in the mountains far away from civilization. So the white noise in the background is a very low sound. And when we have here the signal from a buried subject from far away, even though the buried subject is far away and thus the amplitude of the signal only very low, it is strong enough to protrude out of the noise, and you can hear a very, very silent beep, beep, beep. Now we add the influence of the high voltage power line or any other much disturbing equipment, and thus obviously the amplitude of the background noise is increasing very much, and you see now suddenly the signal of the buried subject, which is far away, is technically speaking buried in the noise, and instead of hearing beep, 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 we will only hear shh. So what needs to happen in this situation in order to be able to detect the buried subject? Our problem obviously is that we cannot just shout to the buried subject, hey, could you not just please put the transmit power of your transmitter up a little bit? Because even if they would hear you, the transceiver does not offer you the option to make a higher transmit power. At the same time, we don't know where the buried subject is. And technically what needs to happen is we need to make sure that these bars here get so high that they protrude out of the noise. And when they are higher than the noise, then technically speaking, we say that here the signal to noise ratio is again good enough to detect it. In order to make sure that these bars rise, we have to get systematically closer to every potential point on the debris the buried subject could be. And if you want to get systematically closer to any buried, to any position where the buried subject could be, then you have to tighten your filters, tighten the grid, apply a narrower search strip width. And this is exactly what you see here. Cut the search strip width in half. In extreme cases, apply micro search strips. And you understand now as well the technical background of this. With that, we continue. And now the avalanche takes place. Until now, we were speaking about group check, about interference. Now it really goes to the rescue side of it. We look here at the probability of survival curve. Here, the black curve, Swiss data. In the European Alps, we mainly ski in a highly cultivated landscape, which means there is only very little forest left in the European Alps, and therefore the very little forest which is left often has an avalanche protection function, or it is protected winter habitat for the mountains. So we very seldom ski in forests. Compared to here, the North American curve based on Canadian data, you mainly ski in an uncultivated landscape, therefore much more often in forests. And when there is an avalanche in the forest or the avalanche drags you into the forest, very, very often this ends in traumatic cardiac arrest. And traumatic cardiac arrest is unfortunately the least survivable of the three ways you can die in an avalanche. Traumatic cardiac arrest has a survivability of about 0.8 to 1.2%, and in most countries it has never been survived far away from civilization. What are the other two ways you can die of in an avalanche? One is here asphyxiation. we see from about 18 minutes to about 35 minutes, there is a very steep drop in survival chances. We lose in total about 70% of all buried subjects worldwide due to asphyxiation. So the process that you narcotize yourself to death with the self-produced CO2. When you look here at the steepness of the gradient, and we look at the first 35 minutes in total in Europe, after 35 minutes, we have about 30% of the lives left. So 70% lost in 35 minutes, minus 2% per minute. And in North America, it's almost minus 3% per minute. And I show always this statistic to as well justify a little bit for the following techniques, methods, and strategies, why they include quite a high level of detail and why we as instructors should even insist a little bit that people show a certain level of compliance to these rules. Because in a business where every minute is 2 to 3% survival chance, you know, it really matters that you apply these rules in a certain way. And for these rules, we as testers, as researchers, as authors, we have usually tested quite well if a rule really makes sense. And we have only embedded a rule here into this MSI information when we can say, okay, that really has a significant a significant contribution to survival chances. After you have survived 35 minutes, you must have as an absolute condition open airways, otherwise survival is impossible. The next phase here is the hypothermia phase, the third way and most survivable of all of them. Let's continue and let's look at the search. You see here the very basic search overview of MSI with the 4 search phases. We start in signal search, as you are aware of in Avalanche Rescue. We scan for 5 different signal types in maximum. One is visual, one is auditive, one is electronic, that can be a transceiver signal, it can be a RECO signal, it can be a signal from a cell phone search device. Then one is tactile, so the distinct tactile probing sensation when we hit the buried subject with the probe. And the 5th, which is still missing, is obviously the scent, you know, detected here by our 4-legged Avalanche rescue friends, the search dogs. And in transceiver and RECO search, we always try to detect 3 of these 5 signal types at the same time. In order to do that, it is particularly important that the rescuers are not looking at the device, whatever device it is, because in signal search, there is nothing to see or to hear on these devices yet. We are only scanning the surface in a systematic manner for the first signal. This is why you see here the rescuer has the transceiver sidewise of the head. In the beginners and intermediate segment, it is absolutely acceptable that the device is here just in a horizontal position on this level. There is no range optimization for a larger range required. I don't think we need to look here into the different search patterns in companion rescue. Everyone applies the search strip width, which is written on the back of the device. This is based on an ICAR recommendation that the search strip width should be mentioned on the back of the device, and as well the rules for the manufacturers on how to calculate the search strip width is based on a ICAR Avalanche Commission recommendation. We now immediately proceed to the advanced signal search for you, the organized rescue groups. When we have very large avalanches, these zigzag-based search patterns are not useful anymore. As soon as avalanches are very large, you need to have the search strip widths aligned here in this manner, where they are parallel to the contour lines of the terrain. And it is as well recommended that you leave a visual marker each time you start a new search strip. You imagine now the searcher is going over here, then the search strip width up, and when he or she is coming back, there is a visual reference which you see. So you know, okay, I have to stay 50, 60, 70 meters above this. If you don't see that, it is very hard to make here a good coverage and to take advantage of the fortunately very large range modern transceivers provide to you. Sometimes, and this happens at least once or twice a year, someone is pushed below the visual end of the debris. If this is the case, you have to find that out by starting to probe from the bottom upwards towards the visual end of the avalanche. And as soon as you recognize here, oh, the tactile probing sensation indicates that this is not only a natural snowpack, but there are debris below, you have to extend the search area. This is what you all find in our puzzle part, advanced signal search. That means as well that more advanced and professional rescuers can extend the search strip widths. What is the interesting part about that? You imagine you fly in with the first team in a smaller helicopter. Maybe you are only 2 or 3 rescuers. The avalanche is very wide, and you try to cover a very large surface in one go. And for this, you have to understand that the search strip width which you find on the backside of your device is calculated in a manner that it is optimal as well for the large public. So it includes a lot of safety factors which are only necessary if you make mistakes as a rescuer. If you don't make mistakes, and if you even make 3D rotations to really squeeze out the last droplet of range which your device allows you, then you can 50% extend the search strip width of your device, and 50% more terrain covered. That is a big difference. For this, it is very important that you understand how probability of detection works. Many people, unfortunately, have the impression that when this is the middle of our search strip widths, and you have here the widths, that probability of detection is something like this. We have here 100%. And here is the end of the search strip width recommended by the manufacturer. And they believe almost like a digital function, it is crashing down to 0% probability of detection. But the reality is very, very different. The reality is that this is quite a flat curve like this. So even outside of the recommended search strip width by the manufacturer, the probability of detection is not crashing down immediately to 0. This curve is going down very slowly. And when you are very few people and it's a large avalanche, then you should take advantage of that. Because when you can search 50% more of terrain with the same amount of people, and the loss of probability of detection is maybe only 5 to 6%, then this is very well, very clever rescue decision. So This is what you find here in this puzzle part, including obviously as well the limitations you have to be aware of concerning search coverage. And that mainly means for the transceiver world, when you cannot see the end of the search strip width, you cannot count it as searched, because the underlying terrain here, the rock or the soil, this creates 100% shade for 457 waves. The wave resistance of 457 waves in rock or soil is very high. That's as well the reason why, for example, we cannot use the Avalanche transceiver for speleo, for cave rescue. However, we see as well that independently how much snow we have, it is always counting as searched. So when it has filled in here, this terrain trap, and you have here 20 meters of snow, this is all covered by the transceiver, because snow and snow of different densities has the same wave resistance for these very low frequency 457 waves than the surrounding air. So when you have a range of 70 meters max of your transceiver, it doesn't matter if this is 70 meters of air or 70 meters of snow. It's important to recognize the burial depths is not a criteria we have to be afraid of. Or when you search in a spring avalanche and you realize, oh, this is very dense snow, very close to the freezing point, there is no problem, because for the avalanche transceiver, this snow, even at very high density, doesn't represent a higher wave resistance. It does not absorb the energy. We have spoken about the 4 search phases. For the beginners level, we often use with this airport approach model, which I have developed already about 20 years ago. And we take advantage of this analogy between the landing airplane and the transceiver search, in particularly giving people an easy to understand relationship between when speed is important and when suddenly precision starts to be more important. You see here at the very beginning level, there is not even any bracketing done. What is in common for all protocols is when we have found the point with the lowest distance indication, we immediately have to mark that with a visual clue. This is the moment where we would mount probe and shovel and immediately start with the probing spiral. You see here the fine-tuned, further developed probing spiral, which is still a spiral, so an endless geometric shape, but the modified, more advanced probing spiral is based on a 90-degree coordinate grid, which has the advantage that the rescuers are always standing here looking uphill. You see the footprints are always the same. It has the advantage that the rescuers all very well know what has already been covered, what has not been covered yet. When you teach the probing spiral, please try to use the following trick. You see here, the probing spiral has 2 reference axes. This is the vertical axis here, intersecting with the position 1, where we have found the smallest distance indication of the transceiver or the loudest sound of the echo. And we have here the horizontal axis. So you start here, and on the first probing spiral, we always have 1 distance from an axis to a corner, and 1 distance back to the next axis, here the vertical axis. And every time they're on an axis, they quickly look back to the center and check for the proper distance. So here 25. 1 distance to the corner, 1 back to the next axis, 1 to the corner, 1 back to the next axis. Now we proceed out to the second spiral. When we are on an axis on the second spiral, we quickly check, oh, I'm about 50 centimeters away. Now, 1, 2 to the corner, 1, 2 back to the center, 50. 1, 2 to the corner, 1, 2 back to the center, 50. If you teach it like that and they apply it like that, you will see it will be much more systematic, meaning they make a probe hit faster. After the successful probe hit, obviously the probe, which is the only reliable guide for the excavation crew to the buried subject, the probe needs to stay in. The transceiver obviously does not realize that you have made a probe hit, and therefore we need to confirm this fact by using the marking function. A true marking function is today standard, and in MSI we have agreed that triple antenna devices with true marking functions are therefore the minimum standard everyone should respect. And fortunately, the products available on the market offer that even at a very low price. So as long as the marking functions work, and this is for sure the case for about 90% of the buried subjects today, we can let yourself lead by these multiple burial algorithms and the marking function from one buried subject to the next one and the after next one, and so on. So the marking function makes it possible to find multiple buried subjects without having to apply specialized search systems. We will now look at the same airport approach picture again, but this time with the formal introduction of 2 out of the 3 variables of the generic search theory: the search speed and the search precision. And you see, the first time we have to considerably slow down is at distance indication 10. And why do we slow down? Because the effect of slowing down is that we profit of an increase in precision. The second time we slow down is at 3.0, the interface to find search, and the last time it is automatic when we have to start probing. Then we always slow down because suddenly the rescuer has to do something himself and not just wait for the transceiver. And maybe one important remark here: as soon as you reach 10, make sure that you closely follow distance and direction. As soon as you reach 10, make sure that you closely follow the direction indication between 10 and 3. It is very important that you are well aligned. Why is this the case? And why is as well everything based on these 90-degree angles in fine search in a cross, as well as when we apply the probing spiral and apply the probe 90 degree to the snow surface? It's important that you understand this, because then you can as well teach it properly. We change back to our whiteboard, and we have here the transmitter. Now we have here the rescuer, which here coming in at 10 closely follows distance and direction indication. So at the interface of 3.0, when we are projecting forward now a straight line, this straight line will intersect just above the buried subject, and therefore we have no lateral offset to compensate in the fine search in a cross. And obviously we make a probe hit faster. When you did not well align between 10 and 3, then obviously your first axis here has offset either to the left or to the right. And now the question is, where on these search lines with a side deviation will you have the smallest distance indication? And it is obviously Here we are in the phase where all the 3 antennas of the transceivers are working. So we are measuring truly 3D. It is where we have the shortest possible distance between the buried subject and you, and the smallest possible distance means we have here a 90-degree angle. And the same is obviously here the case. We have a 90-degree angle. And when you start probing, and we have here the snow surface, and we have here again the buried subject, hopefully with a transceiver, then where you will find here on the snow surface, the smallest distance indication is of course in the shortest possible distance, giving you here again a 90-degree angle. So when you teach the next time in your rescue group and people ask why you insist so much, why we have to probe 90 degrees to the snow surface, or why in fine search in the cross it is really important that we do it in an orthogonal, in a 90-degree based approach, then you have the proper explanation for it, because that leads to the shortest possible way, the fastest possible way how you can find the buried subject. During find search, we hold the transceiver on knee height. This is not only more ergonomic, but it makes the 3D structure or the terrain roughness of the debris disappear. We hold the transceiver like on an artificial plane above the debris. The rule of having to hold the search device always in the same orientation applies for all the search systems which are based on a 90-degree, on an orthogonal coordinate system. So not only for find search in a cross, as well for the 2 other search systems which are based on 90-degree angles, the micro search strips and the micro box. And the same rules are, by the way, not only valid for the transceiver, but as well for the RECO. When we stay a little bit in the last 2 search phases, fine search and pinpointing, there's a small organizational optimization, which is worthwhile to teach when there are less buried subjects than rescuers, and one buried subject is quite close to the starting point. You very often see that very quickly several rescuers accumulate around the first buried subject, and they all try to solve the find search and the pinpointing in the last 2 square meters simultaneously, almost stabbing each other, even though it would be much better when you arrive here as the first one. Maybe you see 5-3, 4-8, you hear that other rescuers are coming close, you immediately say, 3 meters, 1 signal, I search, you dig. Okay, 3-5, 2-8, 3-2, 2-8, 3-5, 1-7, 1-5, 1-8, 1-5. You remember the interpretation of distance indication? The distance reading on the screen is always the maximum possible distance between you and the buried subject. Therefore, when you have here a reading below 2.0, then at the latest, you place here a so-called reference probe, which can as well be a ski pole, about 1 meter below the potential area of the find, and they immediately start digging here. Why is this reference probe so important? Because it makes sure that you have here the required space to properly finalize your find search in a cross and later on your probing spiral. So this reference probe acts as an artificial distance holder, because these rescuers, when they see you find searching or probing here, psychologically, they always have the tendency to immediately start to dig up here, and you cannot properly end your search and reach a probe hit as fast as possible. What's the end result? By the time you have a probe hit, they have already excavated here about 1.5 cube meters of snow, and therefore in total we have gained time. We have maybe gained 2 to 3 minutes. That doesn't sound much, but 3 minutes in North America is almost 9% survival chance, which means if we would do that now 11 times right instead of wrong in the season we are currently in, then one person more would survive, because it makes 100% survival chance. So we have found one buried subject. We have spoken here a little bit about the different things in the different search phases, and I ask quickly Oivin if we have questions. And Oivin, I hear you much better when you activate the microphone.
You don't do the lip reading too well.
Thank
you,
thank you, not at 4 o'clock in the morning.
A couple of questions. When you were talking about very large avalanches in reference for your initial search, how big are very large avalanches?
Yeah, also I would say as soon as we speak about more than 150 meters, then it becomes harder and harder to keep a proper overview without applying this procedure. And as well, looking at it statistically, 150 meters and more, it's already quite seldom. Huh? In Switzerland, and that's not so different in other countries, the average survived avalanche is 50 by 80 meters, and the average deadly avalanche is 80 by 120. Overall, 84 wide, 100 long. So 150 wide is almost already almost the double of the average.
Okay. Next question. Could you speak to how revisions and changes in the MSI are communicated to subscribers?
Yes. When we push out a new puzzle part or a new revision of the puzzle part, those ones who have an active subscription will automatically get an email that there is a new version available for download. We have automated this.
Okay. And can you speak to if there's anybody from the MRA that has input or suggestions, criticism, etc., on the different puzzle pieces? Can you speak to how they can communicate that to the MSI?
Yes. Also, one option is that they contact a work group member they know, such as you. The other option is they go to the website and they see, okay, info@mountainsafety.info. Then they send us an email with their proposal or their question or their the potential problem they have detected. Then we will discuss that during the next work group meeting, and obviously go back to this person to ask for further details, and then evaluate is a modification required, in which speed is it required, is it only affecting a very specific application case or is it affecting all the users. And in fact, exactly such proposals from people all over the world have as well led to a very important fine-tuning of our material over the last few years. and this maturing process which takes place thanks to the sum of all this input is contributing to the quality of the materials, and therefore such input is highly welcome.
Okay. When a subscriber logs into Safety.info, they see a list of topics, and right now there's a topic called Avalanche and there's a topic called first aid. Can you speak to the possible future developments of different areas of MSI or different topics?
Yes, absolutely. At the moment, as you have recognized, there are only winter-related topics. This is not. This is simply based on the fact that the initiator of this project has the background in snow and avalanches, and it is related to the fact that I could only afford to build up the first prototype case of avalanche rescue, and I could not build up all the topics in parallel. So the next thing we started now is first aid. In first aid, you see now the Avalanche protocol, and the Avalanche protocol itself includes many different modules, such as the pre-hospital treatment, ICPR, the hypothermia staging, the triage algorithm for search and rescue, the transport priority algorithm, and so on. We are now filling more content into mountain emergency medicine, and a few weeks ago we have started the third work group on avalanche prevention and risk management in close collaboration with IFMGA and the Swiss Institute for Snow and Avalanche Research. And the fourth topic, this is now already set, will for sure be a summer topic. We are trying to develop this content in terms of additional topics as fast as possible. As you can imagine, it costs resources. We are as well trying to apply for research grants and governmental support and foundation support in order to speed up this process, because now at the beginning, obviously the development amortization fee generated by the sale of materials is not enough to build up many topics at the same time. So we have to look at funding solutions to speed up this process.
And in that regard, I know the MRA is a bastion of resources in many topics. If there were somebody that's interested in being on one of the work groups for any of the topics, how would they go about doing that?
Yes, so basically the process is when we start a new work group, a new topic, we look for new work group members as well, and very often the approach is that we use the existing work group members as connection points to identify the best possible collaborators for the next topics. And in this case, for MRA, this would be you, Øyvind, and I'm sure that as a ICAR delegate for MRA, you have as well an overview of the specialists in your organizations for other topics than snow and avalanches. We have a very close collaborator with Angela Hase, the president of the American Mountain Guide Association. So you see in every country in many of the important user groups, we have collaborators who then have on the national level the connections to identify who would be interesting people to work with us. And if you feel yourself, okay, I am the best person in the world for this, in the same way you can make a proposal concerning content, you can of course as well make a proposal concerning yourself. And we will consider it. And you are muted, Øyvind. And I assume that this is the sign that I should continue with the remaining presentation.
Hey, yeah, just one more question, Manuel.
Yes.
Charlie. A question to Charlie from Mark. Is this webinar being recorded, and where will somebody be able to find it? Yeah.
It is. You all see that.
It is being recorded. It'll be up on the MRA website soon. Manuel and Schulige, I managed to not start the recording until you were about 3 or 4 minutes in, so we might want to re-record your introduction. But yes, it's being recorded. And let me just add 2 quick things. Øyvind Henriksen, thank you for your leadership for MRA and the in fact, we'll give Manuel a chance to get something to drink. It is 4:26 in the morning in Switzerland, so maybe I'm buying him a much needed cup of tea. But let me also just tell you that Øyvind Henriksen is our coordinator for the MRA with the MSI website. And let me also say that Øyvind has a long history in search and rescue as a member of Snohomish County Search and Rescue and a hoist rescue technician with Snohomish County. And we appreciate his leadership on this. We may very well, and I haven't talked about this with Øyvind yet, but we may very well develop a MSI users group within MRA. We will have, I'm guessing by the end of the month, at least 100 subscribers within the MRA alone to MSI. So I just think there's so much to be learned, and the collaboration within our country will be greatly valuable. And I'll also add that I won't be surprised if the Air Rescue Commission of ICAR, for which I am the president and Øyvind is one of the MRA delegates, if we don't use MSI ultimately as a international library of air rescue related topics and publications, not just as they relate to Avalanche, but I know the Air Rescue Commission of ICAR supports and loves the work that Manuel is doing. And with that, Manuel, we will throw it back to you, but I do want to remind us that for our East Coast friends, it's 10:27 at night. I shouldn't be reminding the guy who's up at 4 in the morning, but Manuel, if you want to give us a brief of what the remainder of the program will be tonight, and those that might need to turn in for the night will know that it's being recorded. So tell us what's coming up and how much more time we have, and
yeah,
we'll turn it back to you.
Originally, I planned to go now to the full hour, which would be about 30 minutes more. We'll learn about deep burials. We'll learn about excavation. I will quickly show you that we have content on RECO and of course probe lines. And if you feel that you need to go to bed, then you always have the option to listen to the webinar later. And
Perfect.
Looking at the fact that we have now very much gone into this collaboration model of MSI and so on. It is maybe, because I mean, it is not only about the technical detail on the content here, it's maybe worthwhile that I show you very quickly the site Øyvind and myself and all the other MSI work group members are using to work together and to do all this translation and to get to a best practice consensus, because what you see here is probably the main contribution we really did. So you see here now the start page of the workgroup user interface. And when I log in here and I go to this so-called MSI box, and I need to change now the user interface to English, then you see here all the different puzzle parts. Let's open one. Here, basic snow conveyor belt. Every content has a template. When we work together in MSI, we always first get to consensus on a template. And for new content or major revisions, we have embedded a review function in MSI, and this review function is based on the review procedure of all the scientific journals. So following the same approach, when a template is has reached consensus, then we can start the translations. And only when we have consensus, something is available for translation. So it creates then a translation task. I open here now, for example, the French language layer. Maybe one thing I should have shown here, as long as we are in the main element here of the snow conveyor belt, you see here the technical, the content related discussions, of course, as well with certain replies. As soon as we are here in a language layer, we see here the language discussion, for example, French. For France, language which is spoken not only in France, but as well in French-speaking Switzerland and in French Canada. We obviously have to find consensus on terminology with many people. Here we have a comment of an Avalanche forecaster of the Quebec Avalanche Center, so the East Canadian French-speaking Avalanche Center, a work group member from there, Julie Leblanc, and she has written something about the term of the width of the avalanche. Now, the work group members can start here the editing of it, and when they want to edit content and they need to do here a translation, they have to write here their translation, and here they see the template text based on work group consensus while they translate. Once they did the translation, it's automatically in review state, and the different collaborators get a review task, which then they have to answer either with, say, this is finished, I'm happy, or they have to put something in the language discussion. Afterwards, the language responsible, when everything is done, will go to publish, and as soon as it's published, it's available on the web shop, and the web shop will quickly check who still has an active subscription and has already downloaded this puzzle part, and will send you a reminder that you can download the upgrade for free. So you see that the main contribution we probably did in MSI is to create here an online collaboration and content management tool for all the Avalanche for all the mountain professionals worldwide, and something like that can be used not only in MSI. The generic functionality of that obviously could be used as well in the member organizations which as well work in the domain of mountain safety, either in the rescue domain or in the guiding domain or in the Alpine Club domain, because we all suffer up to now from not very efficient international collaboration. And obviously, when you look at this interface, not everyone speaks English, and therefore the user interface we look at is equally available in these 20 languages. And our French-speaking collaborators, they see here everything in French, and our Russian collaborators, they see everything in Russian. So we make as well sure that people can collaborate with us, even if they are not speaking English, because the tools we have created are available equally in more than 20 languages. So the fact that we realize now, oh, unfortunately, only one topic finished 85%, one topic here finished 10%, and one topic just starting. Yes, this is true, and I would myself prefer very much to have 20 topics finished. But don't forget that all these work group members, such as Oivin, when we started, when the pioneer work group Avalanche Rescue started, first, we worked as well with Dropbox and multilingual PDF files, and everyone was sending in translations to the artwork guy by emails and so on. And it is a major contribution of these work group members from all over the world, from the last 5 to 6 years, to create in the first step not only this content. This is, in my perspective, even the smallest contribution. The biggest contribution is we have created here a collaboration site and a collaboration model which allows us to efficiently reach best practice consensus. And this is not so easy. You know, mountaineers are quite convinced about themselves, are quite hard-headed, characteristics which are important to reach the summit as well in harsh conditions. But for the international collaboration and for a collaborative project, these Penta Alpha people are not always the best. Thus, we really had to very delicately find out how can we develop a collaboration model and a collaboration tool for that. This is, in fact, 80% of the contribution we did. And thanks to this contribution, we will now be able in the future to develop the future topics in a much more efficient manner. And Charlie, you see, I think it was now important to, because it's a general MSI introduction, it's not only about the content. So that was an important point for me, and maybe as well for Oivin to mention. Our real contribution is really, we have created a very efficient international collaboration network for mountain professionals for all the user groups.
Yeah, Manuel, it's huge, and we're so excited, especially with Oivin's leadership, to bring MSI to the MRA. I mean, we just announced this collaboration not long ago, and we'll have more than 100 subscribers from probably 60 or 70 rescue teams throughout the country in no time at all. So we're grateful to you. Thank you.
Perfect. And it's really, you know, it's really not, it's fortunately not a single contribution anymore. I created MSI to make sure that it is institutionalized. It's not about one person. It is a network of all these different collaborators who made this possible. In order to pick now some additional topics for the remaining 20 minutes, after having already presented quite a bit about the transceiver search issue, I will now switch to excavation. And within excavation, I will foremost show a few new developments of the last 12 months in MSI. I will share my screen with you again. You see the snow conveyor belt. You maybe realize we are not speaking about the V-shaped snow conveyor belt anymore. It is still based on the very same basic concepts of the snow conveyor belt we developed 2005 and 2006 in Norway. but we have introduced many refinement steps, and getting rid of the V shape was one of it. So in the normal situation, we all align below the probe which made a probe hit. In MSI materials, when you see a probe in red color, that means this probe made a probe hit. There are only two exceptions when we don't start at the probe, but below the probe. One is very shallow burial depths. Here, with your transceiver search, you maybe had 0.5 as the last distance indication. At the same time, you realize that foot penetration is almost the same. And instead of hurting the buried subject unnecessarily in the last few minutes, you start immediately with two people in the front, 1 meter below the probe. You basically dig down here a snow profile, and you have the buried subject almost in a drawer in front of you, as we always try to access the buried subject from below or from the side. The second exception, when we are not starting at the probe, but below the probe, is when we don't have enough shovelers compared to the required lengths of the snow conveyor belt. And when we say a few things about the general rules of the conveyor belt, first, as soon as you have properly aligned, everyone makes such a half circle shape. The fact that everyone makes that makes everyone recognize here immediately, okay, that's the right border of my segments, that's the left border of my segments. So you don't need to measure the 1.5 meter widths. You make this semi-circle and everybody knows approximately how wide it should be. When you make it much narrower, you increase in head access time because you're too much squeezed in, so you suffer in reduced working efficiency. When you make it much larger than 1.5 meters, there is no additional benefit in work efficiency because it's simply wide enough, but you suffer more and more from an unnecessary increase of excavation volume. And again, head access times increase. So you see this 1.5 meter recommendation. It's a good evidence-based recommendation because we have made many trials narrower and wider, and every time we have proven in the database, and my database has about 600 entries of excavations, every time it is much narrower or much wider, head access times increase, and with every minute they increase, survival chances decrease by 2 to 3% per minute. We dig along the probe, obviously, rotations every 2 to 4 minutes. We rotate clockwise. Please pay attention to the detail that during the rotation, all the members quickly hold the shovel forward as they did in the initial setup procedure. That has the advantage that without having more time, without needing more time for a rotation, after every 2 to 4 minutes, your rescuers are again aligned with the proper spacing. Small detail here, for example, which has been mentioned or proposed by an instructor of the Japanese Mountain Guide Association. Exactly such a proposal as one of you have mentioned to Oyvind before, and we immediately recognized, yes, very clever proposal. Why didn't we realize that earlier? And we obviously have immediately embedded this after a very short discussion in the work group because the advantage was very obvious. Cutting blocks, we leave that out. You can look at that later. When we have first visual contact with the buried subject, then suddenly we have to widen up the tip of the conveyor belt. Now we know how the buried subject is really in the snow, and therefore we put two rescuers kneeling with the shortened shovel shafts in the tip of the conveyor belt. They're responsible for the last 50 centimeters around the buried subject. they first excavate now here from the back these side escape channels before they help to enlarge the cavity which is building around the buried subject. When we look now at this third case here, not enough resources compared to the amount of rescuers you have available. We did a new development. I would like to remind you quickly what the rules are on the lengths of conveyor belt relative to terrain, inclination, and burial depth. So in flat terrain, the length of the conveyor belt is twice as long as burial depths. In steep terrain, it's equal to burial depths. Let's assume we have a 240 burial depths. We are only 3 rescuers in the flat run-out zone. So this is the situation. 240, it's almost flat. It should be 480. Now, every rescuer takes you 80 centimeters of lengths of the conveyor belt. So here we have 80, 160, 240. How much is missing to 480? Equally 240. In order to make sure that the ramp angle of the snow conveyor belt is not getting too steep, we have to start below the probe and to quickly calculate, as a simple rule of thumb, we calculate what is missing, 240. This is how we start now. We dig down half of the total burial depths, but maximum 1 meter. Why maximum 1 meter? Because if you need to lift the snow more than 1 meter vertically, it is extremely strenuous. So here, half of burial depths would be 120. However, it's limited to 1 meter. We equally divide that up in about 30 centimeters each. The green rescuer here throws out the snow as much as possible to the side. He only has to take the first 30 centimeters. The yellow one has to go down in his first segment to 60. So he will start a little bit slower. And the red one here, he has really the hardest start. He needs to go down the entire meter. A little bit later, the green one has already almost reached the probe. The yellow one is slowly catching up, and the poor red one here is still fighting to get down to 1 meter. A little bit later, the green one is at the probe, and now suddenly the game changes because now he needs to go on his own the entire meter down. The yellow one has already caught up with him, and the red one is finishing now the last steps of the lowest 30 centimeters. And when we count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, everyone has shoveled exactly the same volume of snow. A little bit later, they are like that at the probe, and they have created here a deposit space for the snow, which is coming out as they dig out what is still missing. From now on, they apply the standard snow conveyor belt procedure, where you are not throwing the snow to the side, but you transport it along the long axis of the snow conveyor belt. And a little bit later, it looks like that. You have filled in this portion here, and you have accessed the buried subject quickly, thanks to the fact that we made a hole which was not too small. That's a formalization project of this procedure, too few rescuers, which we worked on in the last 12 months. These pictures will now become available on the site in the next few weeks. It is an active running project in MSI. And with that, you have seen something concerning the excavation as well. I go back here to the chat, and I see that we have some questions concerning excavation. Yes, please, Øyvind.
Yeah, I was wondering if you could first speak to the relationship that the MSI has established with the manufacturers and other related organizations like ARI, Petzl, Mammoth, etc. Is there a working relationship with any other manufacturers to any kind and degree?
Yeah, also, I mean, there are amongst the organizations you mentioned, of course, there are very different ones. One is like ARI, commercial mountaineering schools or commercial avalanche schools. In the way how we select work group members, obviously, there are as well work group members from commercial avalanche or commercial mountaineering schools. We, for example, have a member from Safety.info who is teaching hundreds of novice beginner courses every year. He's mountain professional and experimental psychologist, and he brings into our work group the perspective of excellent pedagogical didactical approach for the lowest user group. Of course, I'm not contacting every single commercial mountaineering or avalanche school as part of the MSI network. For example, in the US, I have obviously you, Oivind, and we have as well in the US some representatives who work in this commercial avalanche school business. Concerning manufacturers, I think teaching and commercial manufacturer connections are quite incompatible, and therefore we have planned to make the connection or the interface to the manufacturers mainly via the UIAA Safety Commission. This is where all the manufacturers are sitting anyway, and when MSI content is affected by know-how concerning equipment, then something like UIAA SafeCom is a good platform for that, and it's institutionalized platform. Just last evening, we had a UIAA SafeCom meeting on the new standard, future standard for avalanche probes, and there obviously all the manufacturers were represented. Manufacturer representation in the work groups, I don't see that, and it is as well explicitly mentioned in the operations manuals and bylaws that this is impossible. If we would solve a very specific problem in a work group where a very specific collaboration to solve a certain problem needs a manufacturer, then of course one can invite them for this specific task. But in general, I think to mix up teaching or consulting with commercial interests, this is very dangerous. It should not happen. In the end, you see, the mission of the manufacturer is to sell equipment, and it's not exactly the same mission as we have here. This is not the criticism of them, but as well in forums like, let's say, International Snow Science Workshop, I am always for a very clear separation of what is the trade show and what is the presentation room for the scientific presentations, and it should stay strictly separated. And as well, blended content is for me something which I consider as highly delicate, because when the user is not aware anymore, is this now pure science or is it blended with potential marketing interests, then this is not good. This is not MSI.
Thank you. the Avalanche topic now focuses on avalanche rescue. Do you see there being a development where the MSI would talk about prevention strategies, airbags, terrain selection, etc., etc.?
Absolutely. This is, this is exactly the core of the next work group. When we look here at avalanche prevention and risk management, then you obviously have here all the terrain factors. You have here all the qualitative and quantitative snowpack measurements. You have here terrain selection criteria. You have here the modern risk management systems. So everything which belongs to the prevention part of traveling in avalanche terrain, everything which belongs to, let's say, improvised avalanche forecasting part of it. This is really in here. We officially started this work group mid-December in close collaboration with IFMGA and the Swiss Institute for Snow and Avalanche Research, and as well from the US. Obviously, there will be members in this work group.
Thank you, Manuel. Those are all the questions that have been posted on the chat room right now.
Excellent. As we come to the end, I see I have 4 minutes left. I quickly show you one example here of the additional topics. We have looked at excavation. We as well offer content concerning the RECO search, and concerning the RECO search, please pay close attention to the search preparation component, which we have in MSI. Proper search preparation is key to success for a RECO search. And if you have in your rescue organization or some rescue groups the impression that RECO is unreliable, then I have to tell you, unfortunately, you are wrong. RECO is a very good search device. It's as well a reliable search device, but it is like searching with a transceiver 30 years ago. There is no user error tolerance. Therefore, you have to apply a very strict protocol, and that includes making sure that you are not searching yourself, but the buried subject. Please look at the RECO search protocol from MSI. We have as well things concerning probing. Our probing consent is following the ICAR recommendation on probing. And this puzzle part you see here is in its sequence and in its content based on the respective ICAR recommendation, which we have as well created in the past. And you see here the different coarse and fine probing systems visualized. So if it is about probing, look at the specific content. Look as well at slalom probing. It is the most efficient of all 3 hole per step systems, and it is as well part of the previously mentioned ICAR recommendation. So we have covered tonight things about probing, probe lines, about RECO searches. We have RECO content. We have spoken about excavation. We have touched the subject on transceiver search. Obviously, in transceiver search, there would be many additional things to speak about, like search protocols for deep burials, as we have here, almost 4.5 meter deep burials. So there is more to explore for you in the database. I hope that this initial introduction which showed a few principles of our content and a few modules, and some of the underlying information gave you as well some background information with what considerations we try to create material, and how we try to address the challenge that one needs to provide content on the same subject from the novice level up to the expert level. If there are further questions, you can refer them to Øyvind or to myself or to Charlie, and we will try to answer them. I am sure that when you start teaching, more questions will come up.
Okay, this excuse me, this has to be answered even though it's getting late. So all the MRA members can use the MSI content starting, obviously now. But what is the how do they reference the material used, and what kind of limitations is it for usage?
Okay, yeah, that's a very good question. So the first one, for what can you use it? This is pretty simple. You see it, by the way, every time you read the terms and conditions when you download something. It is strictly for the trainings inside the Mountain Rescue Association, and for the non-commercial training of your own members. If you run on the side an Avalanche school where you teach commercial clients, then you have to get a separate subscription for that, and you certainly have recognized that these small development amortization contributions we ask for are really affordable. And when you use the material in public presentations, this is possible. This is covered under your subscription. So when you make a public avalanche safety or avalanche rescue talk in your community, you can use the material for that, even if the audience is not MRA, but only if this is a non-commercial event and you cannot hand out the content. But if you make a Friday evening avalanche safety talk for the public in your community, the ski touring, the snowshoeing community, and this public talk is provided by you as an MRA member, this is as well covered under this subscription, because it's considered in the benefit of the general society. How to reference the information? This is very simple. Those ones who have already downloaded content certainly have realized that at the bottom of every puzzle part, it has the information embedded concerning the user and license code. I'm just opening here this information so that you see it, and I'm sharing one last time the screen with you. If we have here this puzzle part of the snow conveyor belt, and you see here at the bottom copyright mountainsafety.info, the license code, and here it would say for you, for the Mountain Rescue Association, this must be visible. Huh? This is the source information. This is the legal information which must be part of it, and in most countries it is as well illegal by the intellectual property protection laws to cut away this information. So leave this information inside. If you use complete puzzle parts, or if you use the separate illustrations when you go in the downloaded content in the subfolder files, you obviously get every illustration again separately, and here you see the same information, and you just use in the PowerPoints or wherever you use it, that including this bottom line, and then you have properly mentioned the source.
Manuel, it's Charlie. I just want to thank you so much. Oyvind, I want to give you just a moment for any of your closing thoughts, and then I'll wrap it up. And it's 5:04 in Switzerland. So Manuel, I'm guessing you're not going back to bed. But
no,
Oyvind, do you want to give us some closing thoughts, and then we'll wrap it up?
Yeah, fantastic, Manuel. Really appreciate it. For everyone out there, I've shared my email address. If there's further questions, get in touch with me. And thank you, Manuel, and thank you very much, Charlie.
Yeah, thank you very much to all of you. Thank you, Charlie and Oyvind, to organize this. I wish all of you a nice winter season in despite of COVID. The entire thing will be over in at the end of the summer, at least, when we all get finally these vaccines. Get some good skiing, and use this information, and let us know what you think about it, or if you have better ideas. Thanks a lot. Bye-bye, everybody.
Manuel, thank you. I've just got a couple of closing thoughts really quickly for everybody. First off, Manuel and I first met, gosh, probably 15 years ago in Iceland at a search and rescue conference. And I learned in just one weekend what has been reinforced over many years. Manuel is one of the most cerebral people I have ever met. And the work, Manuel, you've done on MSI is just extraordinary. You know, what dawned on me as you talked about the conveyor belt model of avalanche excavation, that if I was to define MSI, I would define it as almost a conveyor belt, with you as the first shoveler and all of us behind you as your willing students learning to, you know, continue to shovel that information further downhill. You're sort of the top of our avalanche education conveyor belt, and I'm just really grateful to that. So ironic that we talk about avalanches, because on February 18th, our third Thursday live MRA training is Dale Atkins, somebody that Manuel knows well, talking about spring and summer avalanche rescue. On March 18th, the third Thursday in March, drones with Dr. Will Smith out of Teton County SAR, and mission debrief in April, facilitated by Michael St. John out of Marin County Sheriff's Search and Rescue. So if you have not yet been to a third Thursday, just keep an eye on the MRA website, stay on the MRA lister. And with that, I'm going to close. And Manuel, from the bottom of our hearts, thank you for everything you do, and really appreciate you, my friend.
Thank you very much, Charlie. Thank you very much, Oyvind. All the best. Have a nice season. Bye-bye. Good night.
Bonne nuit.
Bonne nuit.
Thank you, everybody.